What is a covalent bond? What are the different types of covalent bonds? A covalent bond is one in which electron pairs are shared between atoms. Electron pairs are shared between atoms. Such a bond is a covalent bond, and such molecules are covalent molecules. If one pair of electrons is shared, then it is a single bond. Single bond. If two pairs of electrons are shared, it is a double bond. If three pairs of electrons are shared, then it is a triple bond. A covalent bond is shown by using a dash between the combining atoms. You can put a dash between the combining atoms. A dash indicates a covalent bond in which there will be a pair of electrons. Aryan, there is a pair of electrons in a covalent bond. Okay. We have seen some examples for single bonds between atoms. Now let us see some examples for double bonds as well as triple bonds. Say, for example, you take O2 molecule, O2 molecule. Say, formation of O2 molecules. We know atomic number of oxygen is equal to 8. Is equal to 8. And the electronic configuration of oxygen will be 1s2, 2s2, 2p, 2p. Yes, complete. You say?
4.
2p4, 2p4. So in the outermost shell, in the valence shell, there are 2 plus 4, 6 electrons. 6 electrons. To complete the octet of electrons, 8 electrons in the outermost shell, oxygen needs 2 more electrons. Oxygen needs 2 more electrons to complete the octet. And if oxygen is forming covalent bonds, how many covalent bonds should be formed by one atom of oxygen? You know, from one covalent bond, an atom gets only 1 electron extra. There is a pair of electrons between the atoms. That is true. If the pair of electrons shared, one electron is one atom, the other electron is of the other atom. So, during the formation of a covalent bond, an atom gets only 1 extra electron. 1 extra electron from the covalent bond. So, to complete the octet of oxygen, oxygen needs 2 more electrons. So, it has to form 2 covalent bonds. Then only the outermost shell of oxygen will be having 8 electrons. So the structure of oxygen will be like this. See, we have the nucleus of oxygen and show the outermost electrons. In the outermost level, there are 4 plus 2, 6 electrons. There are 6 electrons. Say 1, 2, then 3, 4, then 5 and 6. 5, 6. 6 electrons in the outermost shell of oxygen atom. Number 1. Similarly, you take oxygen atom number 2, the nucleus of the oxygen atom, and now you take the outermost shell of oxygen atom. In the outermost shell, there are 6 electrons. So here 2 electrons, another pair of electrons. So 2 plus 2, 4, and 2 more electrons, see here. And there will be sharing of 2 pairs of electrons between the oxygen atoms. 2 pairs are shared. Consider the black circle. Black circle. Within the black circle, there are how many electrons? 2 plus 2 plus 2 plus 2, 8 electrons are there. There are 8 electrons. You take the red circle, the pink circle, there are again 8 electrons. 8 electrons. So, the electronic configuration 2s2, 2p4, it changes to 2s2, 2p6. This changes to, say, 2s2, 2p6, say, by forming 2 covalent bonds. 2 more electrons is obtained by both the oxygen atoms. So the octet will be completed. So the configuration will be 1s2, 2s2, 2p6, and 6 plus 2 plus 2, 10 electrons. There will be 10 electrons totally, and that is the configuration of a 10 electron. Atomic number is equal to 10, and that's equal to neon, the nearest noble gas neon. So there will be the neon configuration. That is neon configuration with 10 electrons. There will be 8 electrons in the outermost shell. So this is the electron dot representation of O2 molecule. This can be shown, say, in another way also. And what is the representation of this molecule in another way? Say, there will be the oxygen atom, there is oxygen atom, and in the oxygen atom, see, there will be 2 lone pairs of electrons, and here there is double bond. 2 pairs of electrons, 2 pairs of electrons will be shared by both the oxygen atoms, 2 pairs. Since 2 pairs of electrons are shared, we say there is a double bond between the oxygen atoms. So you can show this as using the dashes. Say oxygen, double bond oxygen, and here 2 pairs of electrons, and they are free electron pairs. Free electron pairs like this. So there is a double bond between the oxygen atoms, double bond. 2 pairs of electrons are shared by the oxygen atoms, forming a double bond. See? Similarly, let us take another example for the formation of a double bond. And it is carbon dioxide molecule. Formation of a carbon dioxide molecule. In carbon dioxide, we have 2 types of atoms. Carbon atom, atomic number is equal to 6, and the configuration will be 1s2, 2s2, 2p4, 2s2, 2p4. There are 2 plus 4, 6 electrons in the, only, so it is not p4, it is 2p2, 2p2. 6 electrons, totally 6 electrons. So there are only 2 plus 2, 6 electrons. So again, 2 plus 2, only 4 electrons. 4 electrons in the carbon atom. 4 electrons in the outermost shell of a carbon atom. And to complete the octet, carbon needs 4 more electrons, so that the configuration will be changed to, say, 1s2, 2s2, 2p6, 2s2, 2p6, if it is getting 4 more electrons. So that there will be 8 electrons in the outermost shell, 2s2, 2p6, 8 electrons in the outermost shell. So to get 4 more electrons, carbon needs 4 more electrons to complete the octet. See here, to complete the octet in the outermost level, carbon needs 4 more electrons. And so to get 4 more electrons, carbon has to form how many covalent bonds? Achyut, how many covalent bonds? Say from one covalent bond, an extra electron is obtained. Here carbon needs 4 more extra electrons. Yes, carbon has to form 4 covalent bonds. Okay, it has to form 4 covalent bonds. Now you come to oxygen. Atomic number is equal to 8 and the configuration will be 1s2, 2s2, 2p, 4, 2s2, 2p, 4. There are 6 electrons. 6 electrons in the outermost shell of oxygen atom. And to make it 8 electrons, see here, there are only 2s2, 2p4. That means 2 plus 4, 6 electrons. So to make it 8 electrons, oxygen needs 2 more electrons. 2 more electrons. So oxygen has to form how many covalent bonds? Sharon? How many covalent bonds? Sharon?
2.
2 more covalent bonds. So that the configuration will be 1s2, 2s2, 2p6. See? 2p6, 8 electrons in the outermost shell. So carbon has to form 4 covalent bonds and oxygen has to form 2 covalent bonds, and therefore what will be the electron dot structure of a carbon dioxide? You take as the single atom at the center, CO2. In CO2, the single atom carbon, that is taken at the center. See, here we have carbon at the center, the nucleus, and show the outermost shell of carbon. In the outermost shell of carbon, there are, see here, there are 4 electrons. So, 1, 2, here 3, 4 electrons. Outermost shell, 4 electrons. So, the single atom that is shown at the center, and there are 2 carbon atoms, and these 2 carbon atoms are linked to both sides, left and right sides. So, the overlapping of oxygen will be like this. There is oxygen atom and show the outermost shell. In the outermost shell of oxygen atom, there are 6 electrons, 6. Out of this, 2 are used for double bond formation between carbon atoms, and 2 electrons here, and 2 more electrons here. So totally 6 electrons and 2 electrons from carbon atom, so that oxygen can complete its octet in the outermost shell. In the outermost shell of oxygen, you consider the black circle, the green circle. Within the green circle, there are 8 electrons. The octet is completed. And that is the configuration of, so total number of electrons here will be 10, and that is the configuration of a neon, atomic number 10. Both are getting the configuration of neon. Similarly, you take the second oxygen atom, show the outermost shell of oxygen atom. There are, say, 6 electrons. Show the 6 electrons like this. This is the electron dot representation. Electron dot representation of the molecule. That is the structure of a carbon dioxide molecule. Now we can show this using the dashes. So carbon, and on the right side, 2 pairs of electrons are shared. 2 pairs. So there is a double bond between carbon and oxygen. Okay, and there will be 2 pairs of electrons on the oxygen atom, and these are non-bonding oxygen electrons. Similarly, you would think of the left side of carbon. On the left side of carbon also, there are two pairs of electrons. So there will be the formation of double bond here, double bond, say double bond. And say the structure of a carbon dioxide molecule is like this. So there are two double bonds between carbon and oxygen atoms. Two double bonds. Now, I have sent all the notes already. Did you get it or not? You say? Have you got it, Gayatri?
Yes, sir.
Okay. I have already sent the notes. All the notes I have already sent. Okay. So there will be two double bonds between carbon and oxygen atoms. Now, let us take one more organic molecule to show the carbon-carbon double bonds. And it is our ethane molecule. An organic compound. They have studied in the 10th standard. C2H4. C2H4. Ethane molecule. In ethane molecule, there is a double bond between the carbon atoms. You know, atomic number of carbon is equal to 6, familiar to us, and the configuration will be 1s2, 2s2, 2p2. There are only 4 electrons in the outermost level. So to complete the octet, carbon has to form 4 covalent bonds, so that this structure will be changed to 1s2, 2s2, 2p, 4 more electrons, 2p6. There will be 8 electrons in the outermost level. And here total number of electrons 10, and that is the structure. That is the structure of 10, atomic number 10. That is neon, atomic number 10, neon. There will be 8 electrons in the outermost level. Then come to hydrogen. Hydrogen atomic number is equal to 1, and it is 1s1. There is only 1 electron. And hydrogen has to complete its doublet. So to complete the doublet or duplet, hydrogen has to get one more electron. So how many covalent bonds should be formed by hydrogen atom? Lydia?
1.
Huh?
1.
Yes, 1. So that the structure, the electronic structure will be changed to 1s2, and that is the configuration of a helium, atomic number 2, helium. That is the configuration. Now let us show the electron dot representation of a ethene molecule, C2H4. I told you there is carbon-carbon double bond between the carbon atoms. There is double bond between the carbon atoms. So the structure will be like this. Carbon, double bond carbon, say double bond carbon. And there will be 2 more valencies on each carbon atom, and these valencies are satisfied by hydrogen atoms like this. And this is the structure of a ethane molecule. And if you have to show the electron dot representation, it is like this. There is carbon atom, and in the outermost shell, there will be, see here carbon, there will be 4 electrons, and 2 are used for double bond between the carbon atoms, and the other 2 electrons are used for single bond formation with the hydrogen atom. Now you come to the second carbon atom. Second carbon atom here, and say the structure will be like this. Second carbon, there are the size you adjust yourself. Equal size, it is equal size. And here 1 electron, here also 1 electron. See, that is the structure. Now, what about the hydrogen atoms? Let us think of the hydrogen atoms. Here there is single bond with a hydrogen atom. In hydrogen atom, there is a single electron. Similarly, here also the second hydrogen atom with a single electron. Here, third hydrogen atom with a single electron. And here there is the fourth hydrogen atom with a single electron. So that is the electron dot representation. Okay. And these electron dot representations are shown as the dashes shown on the right side. C double bond C. So there is double bond. There is double bond between the carbon atoms. Okay. So during the formation of double bond, two pairs of electrons will be shared. Now come to a triple bond. In a triple bond, there will be sharing of how many electrons? Three pairs of electrons. An example is ethane, that is C2H2. C2H2. As we know, carbon atomic number 6, the configuration is equal to 1s2, 2s2, 2p2. There are only 4 electrons in the outermost level. To complete the octet, it needs 4 more electrons. So how many covalent bonds should be formed by carbon atom, Shivani? Carbon. How many covalent bonds should be formed? Shivani? Shivani?
Sir.
How many covalent bonds should be formed by carbon atom to get 4 more electrons? From one covalent bond, 1 electron is obtained. So to get 4 electrons, how many covalent bonds should be formed by the carbon atom?
4.
Shivani?
4.
4. Yes, it is 4. Okay, let us see. Hydrogen, atomic number 1, and it is 1s1, 1s1. Only 1 electron. Here we have 4 electrons. And the electron dot structure of a ethane molecule will be like this. Carbon atom, the outermost shell, there will be triple bond between the carbon atoms. There are only 4 electrons in the outermost shell of carbon atom. Out of the 4 electrons, 3 are used for formation of triple bond between the carbon atoms. So you can show the 3 electrons here for the formation of a triple bond. And here there is a single electron. Similarly, you take the second carbon atom, and here also there are 4 electrons, and 3 are used for the triple bond formation, and 1 is used for single bond formation. So there will be 3 pairs of electrons between carbon atoms. 3 pairs. So there is triple bond. 3 covalent bonds. 3 covalent bonds. That is a triple bond between the carbon atoms. Then you come to the hydrogen atom. See here hydrogen with a single electron. Here also single electron. Here also there is hydrogen atom with a single electron. See, like this. So there will be hydrogen, single bond carbon, triple bond carbon, single bond hydrogen, and that is the structure of a ethane molecule. And there is carbon-carbon triple bond between the carbon atoms in ethane molecule. Okay. Now let us go to another point, and that is called the lattice enthalpy. Lattice enthalpy. What is meant by lattice enthalpy? Lattice enthalpy comes into play when we deal with the properties of ionic compounds. You take 1 mole of an ionic compound. 1 mole of an ionic compound. As we know, ionic compound is composed of positive and negative ions. Now, the energy required to completely separate 1 mole of an ionic solid into gaseous ions and that is called the lattice enthalpy. So energy required to completely dissociate or completely separate one mole, one mole of ionic solid, one mole of ionic
Sir,
solid
sir,
into, yes,
can you please add Anna?
not seen here. Let her come to the, so nobody is seen here. Okay, so waiting room, nobody is there. Let her come to the waiting room. Okay, energy required to completely separate one mole of ionic solid to gaseous ions, and that is called the lattice enthalpy or lattice energy. Ionic compound is composed of positive and negative ions, and you take one mole of a ionic solid and you heat it, then the ionic solid is converted into gaseous ions, positive and negative ions, and the energy required to separate one mole of ionic solid into gaseous ions, that is called the lattice energy or lattice enthalpy. Lattice energy or lattice enthalpy. So for example, you take sodium chloride. The lattice enthalpy of sodium chloride, that is equal to the value, that is equal to 788 kilojoules per mole. Kilojoules per mole. And what is the meaning of this? What is the meaning of this? You take one mole of sodium chloride. One mole of sodium chloride. One mole of sodium chloride means one mole. How many Avogadro number? One Avogadro number. One Avogadro number. That is one mole. So you take one mole of sodium chloride. That means 6.02 into 10 raised to 23. So much NaCl molecules. That is equal to 1 mole. And in terms of mass, it is 1 gram formula mass. 1 gram formula mass. That is equal to 1 mole of sodium chloride. And it contains 6.02 into 10 raised to 23 NaCl particles will be there. NaCl. And this is dissociated into Na plus and Cl minus ions. So how many ions? From one sodium chloride, see here, from one sodium chloride you will get one Na plus and one Cl minus. So from one mole, you will get 1 mole, 6.02 into 10 raised to 23. 1 mole of Na plus ions and 6.02 into 10 raised to 23. 1 mole of Cl minus ions. So there is complete ionization or a complete separation. And the energy required for breaking 6.02 into 10 raised to 23 NaCl molecules to form 6.02 into 10 raised to 23 Na plus ions and 6.02 into 10 raised to 23 Cl minus ions in the gaseous state. Sodium chloride is in the solid state. Sodium chloride is in the solid state, and that is broken into the gaseous ions. And the energy required to separate 1 mole of ionic solid into the respective ions in the gaseous state, that is called lattice enthalpy. Lattice enthalpy. For example, lattice enthalpy of sodium chloride is equal to 788 kilojoules per mole. That means for the complete dissociation of 1 mole of NaCl, 6.02 into 10 raised to 23 NaCl molecules into the respective ions, Na plus and Cl minus ions. That means 1 mole of Na plus and 1 mole of Cl minus ions. That energy required, that is called the lattice enthalpy of sodium chloride. That is the meaning of this. So in general, lattice enthalpy is the energy required to completely separate 1 mole of ionic solid into the gaseous ions. Let us see two more simple points. One is bond length. Bond length. Bond length. You take a covalent molecule. A covalent molecule. Suppose A and B forms a covalent molecule. Now you take the equilibrium distance. The equilibrium distance between the nuclei of A and B. That is called the bond length. So bond length or bond distance is the equilibrium distance between the nuclei of the combining atoms. Say for example, here there is the nucleus of atom A, and here there is the outermost shell. This is A. Now there is the nucleus of the atom B, and this is the outermost shell of atom B. Suppose there is formation of a covalent bond, that is sharing of a pair of electrons. So there is formation of a covalent bond. Now you take the distance between the nuclei, of the combining atoms, and that is called the bond length or bond distance. Bond length can be measured by using spectroscopic methods, electron diffraction methods, X-ray diffraction methods, etc. And one more point we have to see, that is the bond angle. Bond angle. What is bond angle? Say you take a covalent molecule. Say for example, covalent molecule HOH. Covalent molecule HOH. There are two covalent bonds. Now you measure the smaller angle between two covalent bonds. That is called the bond angle. The bond angle. You can measure the angle like this also. That also you can measure. Reflex angle, is it not? The larger angle is called the reflex angle. No, I have said nothing at all. Just leave it. The larger angle, that is angle more than 180 degrees, reflex angle. Not that. You take the smallest angle, and that is called the bond angle. Angle between two covalent bonds. That's called bond angle. For example, in water, the bond angle is 104.5 degrees. 104.5 degrees. That is the bond angle in water molecule. We are measuring the smaller angle between two covalent bonds, or the angle between the shared pair of electrons. Here there is a pair of electron. Here also there is a pair of electron. So the angle between the shared pair of electrons. The picture is not that clear, but if I say like this, the angle between two covalent bonds, that's called the bond angle. The bond angle gives an idea regarding the shape of the molecule. Bond angle determines the shape of the molecule. So bond length, bond angle, all these are coming into play when we deal with the covalent molecules. Only covalent molecules. Bond angle and bond length. But you can consider the lattice enthalpy, that is seen mainly in the case of ionic solids. So that is enough for today, I think. Okay. So it is time. So let me stop now. Is it time to stop? No, not finish. Up to 4:20, we have to take the class. 4:20. To 4:20, I thought that it just at 4:10. Okay, let us continue till 4:20. Let us continue up to 420. Okay, come on. So let's revise what we have done so far. Okay. Atul, Nia, Rajas, Lydia, Shivani, Sharon, Aaron. I am taking the attendance again. Okay. So, what all things we have seen so far? One is covalent bond. What is it? Emmanuel, what is a covalent bond? Fast, fast. Unmute and say.
It's bond
Bond formed by?
atoms
Yes, atoms. How? Bond formed by?
by sharing the
Sharing of
the-
electron pairs. That is a covalent bond. If only one pair of electrons is shared, that is, come on, Emmanuel, finish it. One pair. Unmute. Come on. One pair is shared. It is called a
single bond.
single bond, covalent bond, single covalent bond. Two pairs, come on.
Double bond.
Double bond, three pairs, triple bond. Only up to that we consider. Only up to that it will be there. Okay. Then we had seen some examples for a single bond, a double bond, and a triple bond. We have seen some examples. Okay. Then we had seen lattice enthalpy. What is lattice enthalpy? Lattice enthalpy, that is the energy required. Nia, the energy required. Aryan, you are there. Yes, come on, get up. Say.
Yes,
Now, what is lattice enthalpy? The energy required to separate 1 mole. Naveen, please complete. Please complete. The energy required to separate. Naveen.
Energy required to separate 1 mole of
Separate
1 mole of ionic solid
1 mole of ionic compound into the respective ions in the gaseous state. Gaseous state. 1 mole of ionic solid. The ionic compound is in the solid state. And that is separated into the gaseous ions. So first it is melted to liquid state. Then the liquid is converted into the gaseous state. Okay. Okay. Then the point that is bond length. What is bond length, Vidur? Bond length. Come on, fast.
The distance between
Distance between
two nucleus.
the nuclei. Yes. Between means two. Between means two. Distance between two nuclei of the combining atoms in a covalent bond. It is seen only in the covalent bond. Then another thing, that is the bond angle. Bond angle. What is bond angle, Lydia? Bond angle. Come on. That is also considered with the covalent bonds. Come on.
Angle between
Angle between two covalent bonds. That is called the bond angle. When you measure the angle, the smaller angle is to be measured. Maximum angle between two covalent bonds is only 180. 180, that is the maximum limit. And the other angles will be less than 180 only. Maximum 180, we can see some examples for 180. Maximum angle will be 180 between two covalent bonds, that is 180. And all the other angles will be below 180 only. That is why I told you to measure the smallest angle. Is it that difficult? You say? Eh? All the things you have studied, only the bond angle, then lattice enthalpy, and the bond length. These are only the new points. Is it not? Am I right? These are all the new points. Yes, all the things you have studied in the 10th standard. Okay. So there is no problem, I think. I'm sure. Agreed or not?
Yes, sir.
yes, sir.
Naveen, do you agree with me? Aryan, agreed. So let's meet again tomorrow. Okay. Thank you.